space, weight is money. And at DexMat, we have a product that can reduce the weight of most satellites by hundreds of pounds. My name is Dmitry Tsentilovich, and I'm the COO of DexMat. By replacing the copper-braided EMI shielding on this cable with carbon nanotube film, we are able to get a cable that performs at spec and is more than 50% lighter than the copper-based version of this cable. Considering that most satellites have miles of cable on them, our products offer tremendous potential launch cost savings, enhanced payload capacity, as well as novel spacecraft designs. If you just focus in on the launch cost savings, for a typical satellite like the one shown in this slide, we have 20 kilometers of cable. At an estimated launch cost of $22,000 a kilogram, a 50% cable weight reduction would result in 170 kilograms of weight savings, and that translates to potential cost savings of almost $3.7 million. And while the total space satellite market for cable is only valued at about $50 million, our products also offer tremendous advantage for commercial as well as military aircraft, and the global aerospace wire and cable market is valued at over $2 billion. With funding from SBIRs from NSF, NASA, and the United States Air Force, DexMat has been able to develop a proprietary, scalable process for producing carbon nanotube fibers and films that are the highest conductivity carbon materials commercially available right now. We have a patented process for taking disordered carbon nanotube powders, dissolving these nanotubes in acid, and then by applying traditional polymer processing techniques like fiber sanding and film casting, we are able to make highly aligned and very well packed carbon nanotube fibers and films. And it's this alignment that gives our carbon nanotubes much higher conductivity than anything that our competitors are able to achieve. Where we see ourselves in the value chain for the cable process or cable product is a critical component supplier for the shielding element of these cables. We purchase carbon nanotubes from our trusted suppliers, and then we make the fibers and films from these nanotubes that we sell to our cable manufacturing partners. And we've partnered with companies like Times Microwave and Minnesota Wire so that they can help us with the final cable assembly, cable testing, and use their distribution channels to deliver cables and harnesses to the end-use customers like Boeing, NASA, and Lockheed Martin. Our team is very talented, and we have an extremely strong engineering background. DexMat was founded in 2015 in Houston, Texas, and our core competency is scalable manufacturing of carbon nanotube materials. We have tens of years of experience in processing carbon nanotubes, and our CEO has led technology development all the way from concept to fully developed product phase at both large and small companies. While we are currently fully focused on developing our materials for use in cable EMI shielding for lightweight aerospace cables, we really have a platform technology that has a lot of other applications. And already, we have sales to paying customers for use of our materials for their conductive properties in applications like flexible batteries, supercapacitors, heating and cooling elements, sensors, and electric motors. And we also have companies that are buying our materials for their mechanical properties in applications like composites, protective garments, and even water purification. Over the next few years, we're planning to expand and start marketing in other areas where we believe our products have a lot of potential value, and this includes wearables and the textiles. And in the 5 to 10 year time window, we also think our carbon nanotube fibers and films can make a huge impact in bioelectronics applications. The most developed technology that we currently have is the lightweight carbon nanotube-based EMI shielding, and we're confident that the 50% weight reduction that our products are able to offer is going to lead to the rapid adoption of our materials. Thank you for your attention, and if you'd like to learn more about DexMat, please visit booth number 820.
Thanks, Dimitri. So James has a question.
So normally, particularly in spaceflight applications, when we look at trading cost and weight complexity, we do a trade against multiplexing, and so we'll multiplex a lot of signals onto one wire and reduce them. Your product seems expensive, so have you looked at your primary competitor, which is the trade between multiplexing and the cost that drives as opposed to the shielding cost directly?
So we actually have not evaluated the advantage of multiplexing versus just using the shielded cables, but regardless of that approach, and I'm sure that it's going to deliver a lot of value, you're still going to be using shielded cables in space as well as in aircraft, and anywhere where you have a shield, you have the potential to reduce weight. So that doesn't mean that it's the only way to reduce weight, but a combination of a multiplexing approach and also using lighter weight materials is going to be something that's beneficial to both aircraft as well as satellites.